graph a polynomial that's in factored form, we start by setting each factor equal to 0 and solving for the x-intercepts. So in this function, the first factor is x, so we set x equal to 0. The second factor is x plus 2, so we set x plus 2 equal to 0, and to solve for x we would subtract 2 from both sides to get x equals negative 2. And the last factor is x minus 3. Set that equal to 0, and to solve for x, we would add 3 to both sides. So we get x equals 3. So our three x-intercepts are x equals 0, x equals negative 2, and x equals 3. Step 2 is to plot those x-intercepts. So x equals 0, and x equals negative 2, and then x equals 3. Those are our three x-intercepts. Now for the third step, we test a point between each consecutive pair of x-intercepts by plugging that point into the function. So for example, between negative 2 and 0, we could choose the number negative 1. So we will find f of negative 1 and plug that number into the function. That would be negative 1 times negative 1 plus 2 times negative 1 minus 3, which is negative 1 multiplied by 1 multiplied by negative 4, and the result is positive 4. So step 4, if that result is positive, we're going to draw the graph above the x-axis, and if the result is negative, we draw the graph below the x-axis. Since the result of plugging in negative 1 is 4, a positive number, we'll draw this part of the graph above the x-axis between negative 2 and 0 on the x-intercepts. And now we continue between the next two intercepts, 0 and 3. We choose any point in between those. So we could choose the point 1 or 2 or some decimal point, but 1 is an easy number to plug in. So we'll find f of 1, which would be 1 multiplied by 1 plus 2 multiplied by 1 minus 3. Because we plug in 1 for every x, that gives us 1 multiplied by 3 multiplied by negative 2, and that result is negative 6. Step 4 says if the result is positive, draw the graph above the x-axis, and if the result is negative, draw the graph below the x-axis. So between these intercepts, we'll draw the graph below the axis. So it only remains to determine what happens on the ends of the graph. To do that, we'll choose any number to the left of the most left x-intercept, negative 2. So we could choose the number negative 3. And again, we'll find f of negative 3. That would be negative 3 multiplied by negative 3 plus 2 multiplied by negative 3 minus 3, which is negative 3 times negative 1 times negative 6. Negative 3 times negative 1 is 3 times negative 6 is negative 18. Since that result is negative, to the left of the x-intercept negative 2, the graph is negative. Finally, we choose a point to the right of the rightmost x-intercept. Since that x-intercept is 3, we'll choose the number 4, which is on that side. f of 4 is 4 times 4 plus 2 times 4 minus 3, which is 4 times 6 times 1, which is positive 24. Since that result is positive, to the right of this x-intercept, the graph is above the x-axis. This process is called sign analysis, or plotting a polynomial by sign analysis. So really all we do is we find the x-intercepts, and then we choose specific test points between and on either side of the x-intercepts. And if those test points give positive results, we know that for that whole interval, the sign of the graph is positive or negative, so we know where to draw the graph, whether above or below the x-axis. Let's do another example. Graph g of x equals x squared times x plus 2 times x plus 5. First thing we do is we find the x-intercepts by setting each factor equal to 0. Setting x squared equal to 0, we would solve by square rooting, taking a square root on both sides to get x equals 0 for the first x-intercept. Then x plus 2 equals 0 is the next factor. Subtract 2 from both sides to get x equals negative 2. Set x plus 5 equals 0. Subtract 5 from both sides to get x equals negative 5. So our three x-intercepts are 0, negative 2, and negative 5. And now we perform sign analysis by choosing a point in each interval between the x-intercepts. So let's start with between negative 5 and negative 2. We could choose the number negative 3. So that means plug that number in for x into this function. G of negative 3 would be negative 3 squared times negative 3 plus 2 times negative 3 plus 5. That would be positive 9 multiplied by negative 1 multiplied by positive 2, which is negative 18. Since that result is negative between these two x-intercepts, the graph is negative or below the x-axis. Now we choose a number in this interval. We can choose the number negative 1 between negative 2 and 0. So we find g of negative 1, which is negative 1 squared times negative 1 plus 2 times negative 1 plus 5. That result is negative 1 squared is 1, negative 1 plus 2 is 1, negative 1 plus 5 is positive 4, 1 times 4 is positive 4. Since that result is positive, we draw the graph above the x-axis between these two x-intercepts. And now we can choose a point on either side to determine the end behavior. So a number that we could choose to the left of negative 5 would be negative 6. So we find g of negative 6, which is negative 6 squared times negative 6 plus 2 times negative 6 plus 5. Negative 6 squared is 36 times negative 6 plus 2 is negative 4 times negative 6 plus 5 is negative 1. Multiplying these together, we end up with a positive result of positive 144. Since that result is positive, to the left of negative 5, the graph is above the x-axis. And finally, we choose a number to the right of the furthest right x-intercept, which we could choose the number 1. Any positive number would work since our rightmost x-intercept is 0. But let's choose 1. G of 1 would be 1 squared multiplied by 1 plus 2 multiplied by 1 plus 5, which would be 1 squared is 1, 1 plus 2 is 3, 1 plus 5 is 6. 1 times 3 times 6 is positive 18, so the graph is above the x-axis to the right of the point 0. What this creates in the graph is a tangent point, or a point that is tangent to the x-axis, where that x-intercept is a vertex or a valley on the graph.